Sit down, please, sit down. I want to ask you something. It's a simple question, and I want you to really think about it before you answer, because if you answer too fast, you're going to be wrong. And you're going to be wrong in the most interesting possible way. Here it is. What time is it right now? You looked at your watch, didn't you? Some of you looked at your phones. Maybe a few of you just guessed based on how hungry you are or how tired you feel. And here's the thing, you all got the same answer, roughly, within a few seconds of each other. And you thought nothing of it. Of course, you got the same answer. Time is time. We all live in the same time. The sun rises, the sun sets, we synchronize our watches, we agree on noon, we agree on midnight, and that's that. Now, let me tell you something that is going to bother you for the rest of the evening. There is no right now. Not in the way you think, not in the way you feel it in your bones when you wake up in the morning and you absolutely know that the whole world is waking up with you. It isn't. And when you really start to chase that idea, when you follow it to where it actually leads, you end up somewhere so strange, so genuinely alien to your human intuitions, that the brain does something remarkable. It doesn't just fail to understand. It actively refuses. It says, no, that can't be right, let's go back. It retreats to the familiar. And that retreat, that psychological flinching, is exactly what I want to talk about today. I want to talk about what happens inside the human mind when it tries to imagine time the way the universe actually runs it, as opposed to the way our particular chunk of carbon and water has been built to experience it. I want to talk about alien time. Not the time of creatures from another planet, though we'll get there, I promise, but the time that exists at the edge of black holes, in the hearts of neutron stars, in the cold, dark stillness between galaxies, and even, if you're patient, in the mathematics underneath everything we think we know. Time as it truly is, not time as evolution has prepared us to feel it. Let me start with something simple. When was the last time you looked up at the night sky? Not through a window, not in a photo, I mean really looked. Went outside, lay on your back, and stared up, because here is what you're seeing when you do that. You are not seeing a snapshot of the universe. You are seeing a collage of different moments, all layered together and arriving at your eyes simultaneously. That star over there, that light left it 40 years ago. That smudge you might mistake for a star is actually a galaxy, and that light is 2.5 million years old. And that faint streak you can barely make out at the edge of your vision, that light started its journey when there were no human beings on this planet. Not primitive ones, not proto-humans, nothing. The Earth existed, but it was empty of anything that could ever look back. So when you look up, you are not seeing where things are. You are seeing where things were. And when they were is different for every single point of light in that sky. The universe does not have a single timestamp. Now this is the first place where the human mind starts to wobble. Because we are built, deeply built, biologically wired, to understand space and time in terms of what's happening right now, right here in our immediate vicinity. You reach for a cup of coffee, and you don't have to correct for the travel time of light to compute where the cup is. You just reach. The computation happens below the level of consciousness because for any object within arm's reach, the correction is so tiny, a few nanoseconds, that evolution never needed to build the machinery to handle it. We are exquisitely calibrated for the scale of human life. Walking speed, arm's length, seasons, decades. That is our native range. Step outside that range in either direction, either very large or very small, very fast or very slow, and the machinery fails. Not gradually, not gracefully. It fails hard. The concepts stop working, and you get this feeling, this very specific cognitive sensation that I think every physicist has felt at some point in their career, which is, I can do the mathematics, but I cannot picture it. And that is a strange thing, isn't it? To be able to calculate something that you cannot imagine. Let me tell you about a man named Albert Einstein, and I know you've heard the name, but stay with me, because the part of the story I want to tell is not the part you usually hear. In 1905, Einstein was 26 years old. He was working in a patent office in Bern, Switzerland. Not at a great university, not in a prestigious lab. He was reading other people's patent applications for inventions. And in that same year, this is astonishing, he published 4 papers, any one of which would have made him famous for the rest of history. The one I want to tell you about is the special theory of relativity. Now, there are many ways to explain where that paper came from, You can talk about the Michelson-Morley experiment, which had been puzzling physicists for almost 20 years by showing that the speed of light seemed to be the same no matter which direction you measured it in. You can talk about the work of Lorentz and Poincaré, who had some of the mathematics already worked out. But Einstein himself said something different. He said the key idea, the thing that unlocked everything, was a thought experiment he had been carrying in his head since he was 16 years old. He had been trying to imagine what it would look like to ride alongside a beam of light. Just that. Just, suppose I could travel at the speed of light. What would I see? The question sounds almost childish, doesn't it? You can imagine a 16-year-old boy lying in the grass, staring at the sky, dreaming. But the reason it's not childish is that when Einstein actually tried to answer it, when he pushed the question all the way to its logical conclusion, he found that the answer was impossible. Not just strange, impossible. If you rode alongside a light wave, you would see an electromagnetic oscillation frozen in place. But that cannot be. Maxwell's equations, which describe how light works, have no solutions for a frozen electromagnetic field. A frozen light wave cannot exist. Yet clearly light does exist, and there is no reason why you couldn't in principle go faster and faster until you caught up with it. Something had to give. And what Einstein realized after 9 years of thinking, 9 years of living with this question that he couldn't shake, is that the thing that had to give was our assumption about time. Our assumption that time is a fixed, universal background, that it ticks at the same rate for everyone, that simultaneous is a meaningful word. It isn't. Two events that are simultaneous for you are not simultaneous for someone moving relative to you. This is not a philosophical statement. This is not a metaphor. This is a measurable, testable, verified fact about the physical universe. We have checked it with atomic clocks on airplanes. We have checked it with GPS satellites. Every time you use your phone's navigation system, your phone is correcting for the fact that the satellites are moving relative to you and are also at a different gravitational potential. And both of those factors shift their clocks relative to yours. And if we didn't correct for that, your GPS would drift by several kilometers per day. So the next time someone tells you that relativity is theoretical, you can tell them your phone disagrees. But here's where I want to really slow down and think carefully, because this is the point where the interesting thing happens. When I tell you that time runs differently depending on your velocity and your position in a gravitational field, when I say that a clock on the floor of this room actually runs very slightly slower than a clock on the ceiling, because it's deeper in Earth's gravitational well, you nod. Maybe you write it down, and you think you understand it. You don't. I don't say that to be rude. I say it because I've thought about this for decades, and I don't fully understand it either. And what I mean by understand is something very specific. I mean, can you feel it? Can you genuinely imagine it, the way you can imagine a baseball flying through the air or a cup of coffee cooling on a table? Can you picture yourself standing at the foot of a mountain and then walking to the top and actually feel in your body that you are now slightly older than your twin who stayed at the base? You cannot. Nobody can. And the reason nobody can is that our brains were not built to notice effects of that size. The gravitational time dilation between sea level and the top of Mount Everest over an entire lifetime adds up to about 30 milliseconds. 30 thousandths of a second. You could not notice that even if you were looking for it. The neural machinery that tracks time in your brain doesn't work on those scales. But here is what is wonderful about that limitation. It means that the universe contains things our brains cannot naturally grasp. That is not a failure of physics. That is physics telling us something profound about how wide and strange the cosmos truly is. Now let me take you somewhere more extreme. Imagine, just try. Just bear with me for a moment. You are falling into a black hole. Not a fictional black hole from a movie. The real thing. You are in a spaceship, and you have crossed what physicists call the event horizon, which is the point of no return. From your perspective, nothing weird happens right at that moment. You don't feel a sharp boundary. You don't hear an alarm. The laws of physics work normally inside your ship. But if you could somehow look back, and you can't, this is a thought experiment, you would see the entire future of the universe unfold in front of you. Everything that will ever happen in the cosmos outside the black hole would, in a sense, be compressed into the finite time it takes you to fall to the center. Meanwhile, to an observer hovering just outside the black hole at a safe distance, watching you, they would see something different. They would see you slow down. You would appear to them to be falling in slow motion. Your clock, if they could read it, would appear to run slower and slower. Light from your ship would become more and more redshifted. And eventually, as you approach the event horizon, you would appear to stop entirely, not die, not pass through. You would be frozen, suspended, a photograph of a moment that never completes. Two observers, same event, completely different accounts of when it happened. And now here's the question I want you to sit with. Which one of them is right? This is where the human mind really hits a wall, because we are used to the idea that there is a fact of the matter. Either you crossed the horizon or you didn't. Either you're inside or you're outside. Either it happened or it didn't. We believe in a single objective reality, and what general relativity is telling you is that when something happens is not an objective fact. It depends on who is asking and how they are moving and where they are in a gravitational field. Now, I want to be careful here. I am not saying reality is subjective. I am not saying physics is just a matter of perspective. The laws of physics are the same for everyone. Energy is conserved. Charge is conserved. The speed of light is the same. What is relative is the coordinate system you use to label events. What now means, what simultaneous means, what duration means. Those are labels, not fundamental features of the universe. The universe doesn't come with timestamps printed on it. We put them there, and depending on how you are moving, you will put them in different places. This is actually old news in some sense. Physicists have known this for over a century. But here is the part that still makes me stop and shake my head. We still haven't completely absorbed it. Not really. Our textbooks present relativity clearly. The math is beautiful. The predictions match experiment perfectly. And yet I would genuinely bet you, that if I asked most physicists to describe the universe in their gut-level intuitive picture, they would still, underneath everything, have a kind of secret belief in a universal now, a master clock ticking somewhere, a cosmic heartbeat that everything is secretly synchronized to. We don't have that. There is no cosmic heartbeat. And if that bothers you, then I want you to notice something. Notice that what's bothering you is not physics. What's bothering you is your attachment to a particular model of reality that your ancestors needed in order to coordinate social behavior on the African savanna. Your brain is optimized for a world where time is universal, because in the world your brain evolved in, the corrections are so tiny that they might as well be zero. Your brain's model of time is like a map that's perfectly accurate for walking around your city, but falls apart if you try to use it to navigate from continent to continent. The map isn't wrong. It's just incomplete. Let me shift gears for a moment, because I want to talk about something that I think is even harder for people to absorb than relativistic time dilation. I want to talk about the arrow of time. Here's something funny. Almost every fundamental law of physics is time symmetric, meaning if you took a movie of something happening at the subatomic level and played it backwards, the backwards movie would also be a perfectly valid physical process. An electron scattering off a photon looks the same forwards as backwards. A proton and antiproton annihilating looks the same. The laws of quantum mechanics, the laws of electromagnetism, even with a small caveat I'll get to, the laws of gravity and the strong nuclear force, all time symmetric. And yet here you sit, knowing with absolute certainty which direction time flows. You know that the egg on the floor came from a dropped egg. You know that the smoke curling up from the candle came from the burning wax. You know that the memory in your head came from something that happened in the past, not in the future. You know these things so powerfully, so viscerally, that the idea of them being reversed strikes you as not just unusual, but impossible. So why? If the fundamental laws don't care about the direction of time, why do we experience such a strong arrow? Why does everything seem to be flowing one way? The answer, as best as we currently understand it, is entropy, the second law of thermodynamics. Systems move from ordered states to disordered states, not because they are required to by any fundamental force, but because there are so many more disordered states than ordered ones. If you shuffle a deck of cards, you won't get the cards in perfect order, not because there's a law against it, but because there's only one perfectly ordered configuration and there are about 8 times 10 to the 67th power disordered ones. The odds against order are not just large. They are absurdly, cosmically, laughably large. And the thing that set this process in motion, the thing that gave us a starting point from which entropy could only increase, was the Big Bang. The universe started in an extraordinarily low entropy state, and we don't really know why. This is one of the genuine, unsolved puzzles. Roger Penrose has calculated that the probability of the universe having started in the low entropy configuration we observe is something like 1 in 10 to the power of 10 to the power of 123. That is a number so large that if you wrote 1 0 per Planck volume, the smallest meaningful unit of space in the entire observable universe, you would not have enough space to write it. We do not know why the universe started that way, and that why is where the arrow of time comes from. So here is a deeply strange thing. The direction of time that you experience as an absolute, irreversible, built into the bedrock of reality feature of the universe, past is past, future is future. You can remember one and not the other. This thing that feels more certain than anything else, turns out to be, at the level of fundamental law, an accident, a statistical artifact, a consequence of a mysteriously low entropy initial condition whose origin we do not understand. Doesn't that knock you sideways? Because here is the implication. If the universe had started in a different configuration, if the initial entropy had been higher, there might be no arrow of time, or there might be an arrow pointing in a different direction, or there might be regions of the universe where the arrow points differently. We don't know that such regions exist, but there is nothing in the fundamental laws that forbids them. And if they did exist, the creatures living in such a region would not experience time as flowing backwards from our perspective. They would experience it as flowing forwards in their direction, because their memories would be formed by events that we would call the future, and their anticipations would be for events that we would call the past. And there is no experiment, no observation, no philosophical argument that would allow you to say they are wrong and you are right, because the direction time flows is not written into the laws. It is written into the initial conditions. And there could, in principle, be different initial conditions somewhere else. Now I want to ask you something. Try to imagine being a creature for whom the arrow of time is reversed, for whom memories form from what we call the future. Imagine what remembering would feel like if what you remembered hadn't happened yet. Imagine planning for something that from your perspective already occurred. Imagine grief over something that hasn't been born yet. You can't, can you? And I couldn't quite do it either. I could write the words, I could manipulate the concepts, but when I try to actually simulate that experience in my mind, something breaks. The simulation fails. There's a kind of cognitive static where the picture should be, and that failure is interesting. That failure is telling us something about how we are built. Our experience of time, not just our measurement of it, but our actual phenomenological experience, the feeling of time passing, the sense of being swept forward, is a construction. It is something the brain does, an interpretation imposed on a physical reality that at its deepest level does not have an arrow at all. Let me tell you about one of the most amazing experiments ever done on the subjective experience of time. It was not done by a physicist. It was done by a neuroscientist named Benjamin Libet in the early 1980s. Libet was interested in a simple question. When you decide to move your finger, exactly when does the decision happen? He had people sit in a chair, watch a dot moving around a clock face, and flex their wrist whenever they felt like it. He asked them to note the position of the dot at the moment they first felt the urge to move, and he measured the electrical activity in their brains with electrodes. What he found bothered people enormously. The brain's electrical readiness potential, the signal that precedes a voluntary movement, started about 300 to 500 milliseconds before the person reported feeling the urge to move. The brain was preparing to act before the person was conscious of deciding to act. Now, there is enormous debate about what this means, and I want to be fair. The experiment has been critiqued, replicated, modified, and the interpretation is genuinely contested. I don't want to overstep the evidence, but the question it raises is the right one. What is the relationship between the physical time of events happening in your neurons and the subjective time of your conscious experience? Are they the same? Do they have to be the same? Is there some sense in which your brain is always constructing the present moment slightly after the fact and you are living in a kind of edited replay? There is evidence, good evidence, that the answer is yes. Your brain takes a small amount of time to process sensory information and assemble it into a coherent experience. The experience you call now is not a real-time broadcast. It's a slightly delayed reconstruction. Your now is always slightly the past. And if that's true for you, sitting in this room, imagine what it's like for something larger, for something slower. There are organisms on this planet, and I love this example, I've been using it for years. There are organisms like certain trees, certain deep ocean creatures that operate on timescales radically different from ours. A bristlecone pine tree can live for 5,000 years. The processes by which it responds to its environment, the chemical signals, the growth responses, the adaptation to drought, these happen over years, not seconds. What is now for a bristlecone pine? What is a moment? We don't actually know if such a tree has anything like subjective experience. It almost certainly doesn't. But the question points to something real. The grain of time, the smallest unit that can be perceived and responded to, is different for different kinds of systems. And for a sufficiently alien mind, the grain might be so different from ours that we would not recognize the experience as time at all. Think about a creature that could perceive geological time directly, for whom the drifting of continents was as vivid and immediate as the swinging of a pendulum is to us, for whom a mountain range rising was a quick visual event, like watching a wave roll in, for whom the 500 million years of animal life on this planet was an afternoon. Such a creature would not experience the history of life the way we read about it in books. It would remember it the way you remember last Tuesday. Can you picture that? Really picture it? I can't. Not really. I can say the words, I can check that the logic is consistent, but the actual simulation, the actual attempt to feel what that would be like from the inside, it breaks down. It runs into something that might be the deepest structural limit of human cognition. We can think about different time scales. We can do mathematics that spans from the Planck time, which is about 10 to the minus 43 seconds and is the smallest meaningful unit of time in physics, all the way to the age of the universe, which is about 13.8 billion years. We can calculate freely in that entire range, but we cannot feel it. We cannot experience it. We are pinned experientially to a very specific range, from roughly 1/10 of a second, which is about the minimum duration a human can consciously perceive, to about a human lifetime. That's our native range. Everything outside it we handle with abstraction, not intuition. And here is where it gets philosophically interesting and also, I have to be honest, a little unsettling. If I found a genuinely alien intelligence, not a human, not something evolved on Earth with our biochemistry and our evolutionary history, something that had been shaped by an entirely different set of conditions, a different size, a different speed, a different relationship to energy and entropy. And if this alien intelligence tried to tell me what its experience of time was like, I might not be able to understand it, not because I wasn't smart enough, not because the mathematics would be beyond me, but because I might not have the experiential categories to map onto. I might be in the same position as someone who has been blind since birth, being told about the color red. The words exist, the physics exists, but the understanding, the deep, felt, embodied understanding might be simply unavailable to me. And now here is the part that I find the most exciting, genuinely, ridiculously exciting, and also the most vertiginous. There is already a form of alien time built into the foundations of quantum mechanics. I want to tell you about something called the Wheeler-DeWitt equation. It's a famous equation in theoretical physics developed in the 1960s by Bryce DeWitt and John Archibald Wheeler, and it is an attempt to write down the quantum mechanics of the entire universe, a wave function for the cosmos. And when you write it down, something strange happens. There is no time in the equation, not a little time, not a weird version of time, no time. The equation is static. The wave function of the universe in this formulation is not evolving. It is a frozen object, and yet somehow from that frozen object, the experience of time, the flow, the change, the arrow, all of it must emerge. How? Nobody completely knows. The leading idea, called the Page-Wooders mechanism, is that time is a relational concept. Time is not something the universe is sitting in. Time is something that clocks measure when they interact with the rest of the universe. In other words, time is passing is not a fact about the universe as a whole. It's a fact about how parts of the universe relate to each other. Your clock ticks and relates to other things changing. That relationship is time. This is not philosophy. Or rather, it is philosophy, but it's also physics. Carlo Rovelli and others have developed this idea carefully and rigorously. The universe, at the deepest level we know how to probe, might not have time as a fundamental ingredient. Time might be something that emerges from more basic things, the way wetness emerges from water molecules. No individual water molecule is wet, but get enough of them together in the right configuration, and wetness appears. Similarly, no individual quantum of reality is in time, but get enough of them together in the right configuration, and time appears. And if that's true, if time is emergent rather than fundamental, then an intelligence that could somehow perceive the universe at that deeper, more fundamental level would not experience time at all. Not slowed down time, not sped up time, not time flowing in a different direction. No time. A single, eternal, atemporal view of the whole of physical reality. Try to imagine that. Go ahead. I'll wait. I've tried. I really have. I've sat with it, played with the mathematics, tried every analogy I could think of, and every time the mind slips off it, because every act of imagining takes time. Every thought unfolds sequentially. The very machinery you are using to try to picture an atemporal reality is itself a temporal process. It's like trying to see your own eyes. The instrument of investigation is the thing you're trying to investigate. And here is what I love about that. Not the failure to understand, but the fact that the failure itself tells us something. The failure tells us that the human mind is a very specific kind of physical system. It runs on particular chemistry, at a particular temperature, on a particular time scale, and it was built by evolution to do a specific job: survive in a medium-sized world at medium-sized velocities with a medium-sized gravitational field. It is extraordinarily good at that job. It built the mathematics and the experiments and the instruments that let us see beyond its native range. That is remarkable. That is perhaps the most remarkable thing about us. But the built-in limitations are also part of what we are. And recognizing them, not fighting them, not pretending they aren't there, but understanding why they exist and where they come from is one of the deeper forms of self-knowledge available to us. I want to tell you about one more thing before I'm done, because I think it connects all of this together in a way that has genuinely moved me for many years. In 1977, we launched 2 spacecraft, Voyager 1 and Voyager 2. These are now the most distant human-made objects in existence. Voyager 1 is as of now in interstellar space, more than 20 billion kilometers from Earth. It is still transmitting. The signals it sends back take more than 20 hours to reach us, traveling at the speed of light. And on board each of those spacecraft, there is a golden record, a gold-plated copper disc with sounds and images from Earth, music, greetings in many languages, the sounds of surf and wind and rain and laughter, pictures of humans and their world. We sent them out not because we expected anyone to find them anytime soon. The chances of interstellar encounter in any human-relevant time frame are astronomically small. We sent them as a gesture, a message to the universe. And the message is, implicitly, this is what time is like for us. This is what a moment feels like when you are our size, our speed, our age, our kind. And if millions or billions of years from now, some other intelligence finds that record and plays it an intelligence that might experience time at a rate 1,000 times slower or 1,000 times faster than we do, an intelligence whose now might span what we would call centuries, or might be compressed into what we would call microseconds, that intelligence would hear sounds that to it might rush past in an incomprehensible blur, or might unfold with glacial slowness over what felt to them like an eternity, and they would have to work very hard, very carefully, to understand what a second meant to us, what a moment felt like, what it was like to be a creature that lived 70 or 80 years and called that a life. And I think they would understand, not feel understand, because mathematics doesn't care about the native time scale of the intelligence doing it. The equations of physics are the same for all of us. The deep structure of reality is not species-specific. The speed of light is not a local preference. But here is the beautiful thing, and this is what I want to leave you with. The fact that we, with our tiny built-in time window, our meager evolutionary range, our fragile neurons buzzing along at their particular frequency, the fact that we have been able to reach out and grasp, mathematically, if not experientially, the full 15 billion year sweep of cosmic time, the Planck time at the bottom and the heat death of the universe at the top, the time inside a black hole, and the atemporal ground of quantum cosmology. This is not a small achievement. This is extraordinary. The universe produced a creature that is confused about time, that cannot feel relativistic dilation, that cannot truly imagine the view from a quantum description of the whole cosmos, that experiences a constructed present moment with a slight delay, that has an arrow of time built in at the experiential level by nothing more than a statistical accident at the beginning of everything. And that creature, despite all of that confusion, despite all those limitations, built instruments delicate enough to detect the slowing of a clock at the top of a building compared to its base. Built mathematics that can describe the moment before the Big Bang. Built spacecraft that carry its greetings into the interstellar void. Figured out that the universe has no master clock. Figured out that now is local. Figured out that the arrow of time is not a law, but a memory of an improbable beginning. A confused creature reaching upward with imperfect instruments and finding out the truth anyway. There is something in that which I cannot explain and cannot fully name. It's not pride exactly. It's something more like recognition. Like the universe has become aware of itself through us, briefly, imperfectly, squinting through our narrow experiential window, and has managed, against all reasonable odds, to catch a glimpse of its own strangeness. We don't know what an alien mind would make of time. We don't know if there are alien minds at all. But I'll tell you what I suspect. I suspect that any intelligence, wherever it arose, however fast or slow it runs, however big or small, would eventually discover the same deep truths we have discovered. Because those truths are not about us. They are about the universe. And the universe is the same everywhere. The question that will follow you home tonight, the one I can't answer and that I don't think anyone can answer yet, is this. Is there a form of understanding time that transcends experience entirely? Is there a way of knowing what time is that doesn't require being in it? I don't know. But I want to find out. And I suspect if there are other minds out there, they want to find out too. And maybe that wanting, that irrepressible, unstoppable desire to understand is the deepest thing we could put on a golden record. Not music, not greetings. Just, we were here and we were confused and we looked anyway.